Hello, everybody, and welcome to video 15 in this series. So we're this is part two of our scripting thing, intro to scripting. In the first one, we were talking a little bit about the setup that we have in all our game development things. And for the introduction, the introduction to scripting, we want to just rotate our sun uh, to simulate the passage of time with day and night, the day and night passage of time. And in the first video, we were talking about these values over in the inspector and how we access those are related to the script. We actually have access to all of these. So how do we get them? Let me come up to a different one. I'll go up to light and choose these. So maybe we want to access the light color. If I right click on that here, there's a copy property path, and I can paste that in and light underscore color. Do you see how the name here relates to what we see in this vector? We're in the light section and the color value. Or another one, volumetric fog energy. We can see it when I hover over it, documentation pops up and we can see it, but if I drag that over, we can see the name of it as a string. We don't need it as a string. When we right click and copy the property path, the one we actually would use in our script, paste that in and light underscore light volumetric fog energy in snake case. If you're not familiar with that word, that's all lowercase with underscores. And do you see how that relates to this property in the inspector panel? So we have access to all of those, including the one we want for this intro example, the transform data and the rotation X property and the rotation vector. And we can add stuff too. Let me add one. The syntax for this is a little bit different in all our game engines, but for Godot 4, they've done a lot of stuff with annotations. So we can say at export, and actually annotations have taken the place of the initialization function, but I'm trying to generalize this for game dev. So for these videos, I'll probably continue using this. And if we say export, we need to create a variable. We want to create our own unique variable for our sun object, not the one that's general for any directional light. I'll call it maybe day cycle speed. Whoops, if I can spell speed correctly. And I want to give it a value of 1. So I'm thinking start with 1 degree for the example. So it rotates by 1 degree. And hopefully this part should look familiar for those who know Python. It's the syntax here is based on Python. We add a keyword to say we have a variable, but like Python right now, it's dynamically typed. And dynamically typed languages are slower, and slower is not something we want in our game engine. So for in Godot, if we want to switch this to strictly typed, we use a colon and put the type of data we have. So we want to create a floating point number, and then that's faster because the computer doesn't have to waste any time trying to figure out what type of data it has. It knows it's a floating point number, so it just right from the beginning can go ahead and set up that much space in RAM, and that makes our languages considerably faster. A lot of times we'll do this. The assignment operator also works with the type, so it will infer type from that. I'm going to go ahead and type it out explicitly here for reasons of clarity. And I save that. If we look over at the inspector panel now with the sun selected, you notice right up here, there's the name of the script we're working on, and there's that property we just created. Putting it in a snake case, all lowercase with underscores, and it got reformatted nicely to go in the inspector panel. And then we can just change the value from here when we're working our game. We don't have to come into our script and do it. So we'll do that, and that's how we add things to the panel, and that's how all the stuff that's in the inspector panel showed up there. And that is consistent for all of our game engines. The syntax is a little bit different. This is the syntax for Godot, in particular Godot 4. there was a different syntax up through Godot 3, but they've switched to a lot of annotations in Godot 4. So different engines will put things there differently, but that's how all this stuff showed up in our inspector panel, and we can access it the same way. All you have to do is just ask for it, because we already inherited that. Inherited everything, such as our transform data and our rotation. So here in Godot, I can just right click on it and copy the property path, and it's just the word rotation to access our transform rotation for this object. We'll see references to other objects before long, so maybe we want our sun to rotate our character, but we could do that. But for now, just the word rotation accesses the sun's own rotation, and then we need the x dimension of that vector. And I'll just use the long notation. We'll change that to whatever it was minus that angle in our day cycle speed, which don't run this yet. I'm not going to run this one. Over here, we see degrees when we see it in the spectra panel, but that is a reformatting. This does take radians. If you're not familiar with that, if you haven't had a trigonometry class, when we measure an angle, you can think of it as a circle. Going around that circle, if we're right at the center, the degrees tell us how far we change. But that's not the only way we can measure it. We could also measure degrees at the other edge of the circle, the outer edge. And a good way to measure that is the distance of the radius. So if we take the distance of the radius and go around the circumference that far, that's 1 radian, a different way to measure angles. And from the formula for the circumference of a circle, which you probably saw in like elementary school or something, there's only 6 radii, or 6.2 something radii going around the circle. So if we did this right now, this would go all the way around 360 degrees in 6 frames. So it'd be a bit overwhelming. We need to change that to radians. Because when I put 1 degree, I was thinking like 1 degree per second. There's a built-in function we can use, degree to rad, degrees to radian, and then put our day cycle speed, which is the degrees here. And then it'll just rotate by a little bit. And then it's negative because of, well, when we were over in the view panel and I spun that around a direction when I was talking about it, I was looking over here and just noticed that I was moving in the negative direction there. That should be enough to start spinning our sun and give the illusion of time passing. So I'm going to save that and run the scene and see if that worked correctly. Very, very quick. It's going 1 degree per 1 degree per frame, so it gets around pretty quick. And when I said 1 degree, what probably popped in your mind was a second. That's kind of what I was thinking about, and that's where we use this delta parameter, which again we'll have something very, very similar to that in all of our major game engines. And again, that's the amount of time it takes for the frame to pass. So a very small fraction of a second. So if we multiply the angle we want to move times that small fraction of a second, then over the course of a second, we will move that angle we want. Sort of the basic idea in how we get game scripts going and how we access the values or create new values. So you can see it's moving at a much better speed now. Coming around, we see the morning's passing, the lights coming up over the hills behind us, and the shadows will start changing, and it'll change throughout the day. And we set that as a parameter, so we can set that up faster too. Up here, we exported that parameter, which again is available in all of our game engines. It's just going to be a different syntax on how we do it. But I don't want to list out all the syntaxes right now because that would just be overwhelming. So we switch that to 5 degrees. Moves a little bit quicker. We see the sun come up and over the hills behind us, midday. The shadows are all coming basically straight down. When we pass into the afternoon, the shadows point the opposite direction that they were in the morning. And it gives us a nice little simulation of time in our game. With a quick introduction to scripting there, it did spread out over 2 videos, but uh, I'm trying to keep all the videos under 20 minutes, and the first one was 12, so that looks like, or under 15 minutes. So that would have took 22 minutes in the video, which is longer than one. Then we go to night, where it's hard to see anything. We can still see a little bit, kind of like when we're wandering around at night in the real world. And before long, it should reach day again. I'm going to wait to stop the video until then. So hopefully all this stuff is making sense and on a conceptual level so that you can build stuff so you understand the concepts on how to build a game. That's what we're going for here. I can't remember if I said it in the intro to this video or not. These videos are part of a preparation for a summer camp I'm giving to high schoolers this summer. I have the lecture planned out, and I've made the videos and then making notes and editing that lecture plan. And I've already had some major edits on it from the videos, but I thought I'd go ahead and post the videos on YouTube because other people might be interested in it. So these aren't the final draft of what the lecture is going to be. So hopefully I didn't skip over any major parts in any of the videos, and hopefully you're finding it helpful. And I know I'm finding it helpful for getting the lecture plan together. But that gives us a nice little introduction to scripting and adds a really great effect to our game with basically just one line of code. We didn't really need this line of code. That was just to show you about the inspector panel. And that's how game scripting works. We interact with the inspector panel. Somebody already wrote a script with all these other values on there, so we have access to that from our inheritance. We can add new values to it or do values that are internal to our script. And then in all of our major game engines, we'll have a function for initializing everything that runs one time when the game starts, and then a function that runs every frame of the game. Actually, we have several varieties of those, but keep it simple for the intro here. We have, let's just talk about the one. And what changes to the game engines is the name. So in Unity and Unreal, we have that same setup, but we give them the functions a different name. Otherwise, that's hopefully made a good little introduction. Now we have light in our scene so we can see things happening, and we're ready to start doing stuff with our character. And that's the next major phase to get into is, what do we want to do with our character? Well, immediately we want to get good control, because right now we just have the generic controls that came basically default for a character, move back and forth, and we don't have any control over our camera yet. So we want to get that. But then after that, what do we do with our character? So that's the next major phase in the game. For upcoming videos, I hope you all find this helpful, and I'll see you in the next video.